Now in the last two videos, we've been dealing with vector diagram that involves forces. So let's, for example, you have an object here, you have one force pulling the object here and another force pulling here. We have learned that you can use parallelogram, complete the parallelogram, and the resultant will be diagonally to the right in between the two forces. Likewise, we also learned the tip to tail method. So if I were to draw this force first, then the other force here, I will join to the tip of the first arrow, and therefore the resultant will be here. So both are the same. Now, vector diagram is not solely for forces, so as long as the physical quantity is a vector, you can actually use vector diagram. So I'm going to show you three examples that involve velocity. Take a look at this first question here. So when there's no wind, the engine of an airship will push it due north at 20 meters per second. So the engine itself will just push the airship due north 20 meters per second if there's no wind. And now there's wind blowing from the west. That means west to east. So in this direction, 12 meters per second. Just like you roll a ball straight and then there's wind blowing to the right, you know that the ball will not go straight, it will go diagonally this way. That will be the direction of the resultant velocity. So if you understand that, let's redraw the thing, assuming this is the airship. So first of all, the 20 meter per second velocity due to the engine will be going straight to the north, and the wind is blowing from the west, so it will be to the right, 12 meter per second. Then we complete the parallelogram, and this will be the resultant R. So the answer will be A. Of course, you can eliminate two of the options directly, because if you know that the wind is blowing from the west, so the wind direction, the velocity should be to the right. So these two, the direction are wrong. So straight away you can eliminate. And of course, this one is the same, similar. You know that just like two forces pulling you at 90 degree, you know that you will go diagonally to the right, not to the left. So this is also wrong. All right. Now the second question is quite similar. You have an aircraft that heads northeast. All right, northeast is somewhere around here, and it's 400 km per hour, and the wind is blowing towards the northwest. The wind is blowing this way. So if I were to draw the parallelogram, so this is the aircraft and 400 is northeast, so let's draw it here, 400 km per hour, and the wind is heading to the northwest, and since it's 100 km per hour, it's just the length will be just about 1/4 of it. So likewise, you complete the parallelogram and you know that the resultant will be in between the two forces. Therefore, A will be the answer. So likewise, B, straight away you know is wrong because the wind direction is wrong. It should be in this way. And like I say, you have these two velocity here. The resultant will be somewhere around here. And likewise, D, the wind direction is wrong. Now for this third question here, it's a bit tricky. I was thinking that it's just like question 1, but it's not. Now let's take a look here. A boat crosses a river and arrives at a point due north of its starting point. So this is the river bank, and the boat initially is here, and the final position of the boat is over here, meaning to say that is the resultant. So, and there are two velocity involved here right now. So one is the wind, and the wind is blowing from west to east W, and there's a speed of the boat due to the engine V. Now because there are two, you should know that because the resultant is just due north and there's wind blowing to the right, so that means the velocity due to the engine must be somewhere in this direction. All right, so but if you look at all the options here, all are in terms of tip to tail method, but let's start with something we are familiar with, which is the parallelogram. So if this is the boat and we know that the V will be this way and the wind will be to the right, okay, blowing from the west to east. So one thing to know is the resultant force is vertically up due north. So if you complete the parallelogram, the resultant will be here. But it doesn't look like any of the option because the options are tip to tail. So we have to kind of redraw it to tip to tail method. Maybe let's start with the V here. So it's diagonally to the left. That's your V. And I'm going to join this wind, the velocity W, the tail of the W to the tip of the V. So it will be to the right. So remember, do not change the magnitude or the direction. So the resultant will be here, that's R, and you know that this is exactly the same as C. So C is the answer. But some of you may draw the tip to tail another way. For example, what if you start with your W, which is to the right, which is correct, that's your W, and then you're going to join the tail of the V to the tip of the W, so you draw it this way, and the resultant will be here. But you have to understand that, I mean, you need to play around with it. So just as long you can play around with all the three forces, shift it around, you can either draw this or this, and then see which option is the correct one. And of course, you just by elimination, you know that A is already wrong because the wind is supposed to go to the right, not to the left. Then another thing is this resultant is wrong because the resultant has to be due north. That's where the final position of the boat is. So D is wrong. And for B, why is it wrong? If the velocity due to the engine is to this diagonally here, and imagine this is the boat and the wind is blowing here, then the resultant, if you complete the parallelogram, the resultant will be somewhere around here. It will not be vertically up due north. So C will be the answer. So I hope with these three examples, you should be familiar that vector diagram is not just solely for forces, but can be for any vector quantities like velocity for these three questions. All right, thank you.